and gentlemen, we've come to the final keynote of this conference and to present the topic Shift Left and what it means for testers in the coming decade. Let's welcome Mr. Rex Black, CEO of Rex Black Consulting Services.
Stick your hand up in the back if you can't hear me. Stupid presenter joke there, sorry. Okay, so I'm going to hope that this translates. I'm hoping that does what I expected to do. Yes, so far so good. So this thing that you see right here is what we would call in the United States a 2x4. It's a piece of lumber used in construction. But it's also a sort of a metaphorical thing in that there's a line like if you don't learn from experience, reality will hit you upside the head like a 2x4, which would hurt really bad. So the first time I heard the phrase shift left, I was doing some consulting work for Dell back in the 90s, and I was working with a QA manager there named Ren McNary, great guy, and he was in charge of the Shift Left project, and he had a 2x4. This is a replica of it. I wish I had the actual one. It'd be a classic now. It'd probably be worth a lot of money. He had this 2x4, and he had written on it with a black marker, Shift Left, and he would take it to meetings and wave it around, and I'm going to make us shift left. He was going to persuade people through the 2x4 if necessary. So, this shift left stuff ain't new. Usually what happens is we get new buzzwords, but sometimes I guess they run out of new buzzwords and they use the same buzzword again. So shift left is like it's rebuzzed. It was a buzzword back in the 90s and now it's back. Continuous integration, continuous delivery, continuous deployment, DevOps. Right? Buzzword tornado, whirling around your head. What does all this stuff mean? Are we just doomed? No. Actually, it's mostly good news. Don't worry. Be happy. But be ready to learn and be ready to be an SDET. All right. So, shift left is upstream, basically up the waterfall, if you will, up the V model, except it ain't really V model and it ain't really waterfall. Shift left comes out of Agile and Lean and Kanban and the open source stuff that's been going on for decades. So what is this stuff? Well, I mean, there are definitions, and then there's what people mean when they say it, and those aren't always the same thing. But we can kind of sort of say that shift left is this idea where testing gets moved to the left, earlier in the life cycle. So test early, test often kind of thing. Okay? That sounds kind of familiar, doesn't it? Kind of V-model-y. Kind of basic principle of testing, kind of something that's been around a while. Continuous integration, continuous delivery. So continuous integration is we don't just wait and integrate code someday, like weeks after we build it. We build it, integrate it right away. Well, the developers do. We test it. And then it gets delivered. Well, delivered to whom? Well, it could be delivered in a test. Okay. But it could also be CD means continuous deployment, in which case it's delivered to production. So out it goes. New builds sprayed into production on an ongoing basis. And then you got DevOps. And what is a DevOps? Well, development and operations. This idea of getting the development and operations folks to work together, collaborate more closely, and it usually includes these ideas of shift left and continuous integration, continuous delivery, continuous deployment. A lot of the DevOps stuff grows out of a business frustration that a good 70 to 80% of the time when you have a problem in production, some sort of production incident, it's because somebody changed something. I was working with some operations guys back in May, and that was the statistic they were throwing around. They're like, yeah, most organizations, 70 to 80% of the production incidents they have are because some new software got deployed into production environment by the development folks and it broke something. So that's frustrating. And you know, these incidents, man, these things aren't cheap. I mean, I was snuffling around in their incident data, and you know, we're talking about hundreds of millions of dollars every year in this organization spent dealing with incidents. Now, this is a big organization, Fortune 50 company, but you know, that's kind of what's driving this, is this sort of ongoing business frustration with why do we keep having these problems in production? How come the software doesn't just work? Now, a lot of this stuff is driven by automation. Automation is an enabler, and I'm not just talking about test automation, but test automation is part of it. So what does this mean for you? All right. I like metaphors, so here's a metaphor for you. This is the astronomical clock in Prague. I have bad news for you. If you go there right now, I think it's being repaired, so you don't get to see this, but it's a pretty amazing thing. If you look at the windows up there, you see right there? There's like little people moving in there. This goes on for, you know, a good, I don't know, 3-4 minutes. There's a little, you know, 10-second GIF of the thing, but the whole performance is incredible. And then this, you know, this is pretty remarkable too. This doesn't just tell time. Now, this is a metaphor that if a black box tester is kind of like somebody who knows how to read the clock and knows what time it is, right? The SDET, the technical tester, the white box tester, knows how the clock works. Now, you might say, SDET, what do you do? SDET, white box tester? Okay, so think ISTQB technical test analyst. Okay? That's what this term means. Software Development Engineer and Test, SDET, or Software Engineer and Test, SET. Get ready, you're going to be hearing these terms a lot because they are all over the internet in the United States now about, you know, you go out on LinkedIn and there's just like SDET this and SDET that, and it's, you know, this is a buzzword. You can like it or not, but, you know, that's a word. So whatever we want to call it, are you an SDET? Well, yes, you want to be an SDET. We have had a long-term trend in increased requirement for technical skills for testers, and this is where we are now, SDETs, highly technical testers. Don't just know how to use tools, but know how to build tools and customize tools, know how to use scripting languages like Ruby and Python, know how to read code, maybe even write code. If you're sitting there going, oh, I don't know if I want to learn how to write code, get over it. Okay, learn how to write code. It's not that hard. It's not magic. It's just code. Okay? Learn how to script first and then learn how to code if you don't know how to code yet. But you know, you're going to need to do this. So you might go, oh, okay, you mean I need to know how to automate tests? Yeah. Okay, you do. But more than what we've traditionally meant, well, traditionally is the wrong word, because traditionally, as I'll mention a little later, this is exactly what we meant by automating tests. But over the last, say, 20 years, we took a wrong turn with automation, test automation. Everybody's like, got to automate through the graphical user interface. Because if we're not automating through the graphical user interface, that's not how the user's going to use it, and so it's not real testing. We have a word for that kind of logic in the United States. It starts with the word bull. I won't end it. Okay? That was a bad idea, this idea that we have to automate through the graphical user interface, because graphical user interfaces are brittle. And so the scripts you write scripting through the graphical user interfaces, they break and they're hard to maintain, and you got to go through all of these gyrations to try to avoid maintainability problems. And there are ways to make it work, but it's like, do we have to do all of the automation through the graphical user interface? No. Let's just do the stuff that has to be done through the graphical user interface, Command line interfaces. Command line interfaces are great. Put a command line interface in your application. How do you do that? Easy. Use something like TCL. Application program interfaces, data layers, network layers. There's lots of ways to talk to applications and systems under test. We don't have to talk to them through the graphical user interface. That's just one place. We also need to keep in mind the idea, which is thought of as an agile idea, of the test automation pyramid. Okay? And it's good branding, this idea that you do a lot of automation at the unit level and less as you go up to the higher levels. Now, that didn't come out of Agile, but that was certainly popularized. So, yeah, do lots of lower level tests and know how to do that. Don't just sit back and go, yeah, that's developers do that. Yay, developers, do the automated tests. Because, the developers don't know about test design. That's what you're going to bring to the puzzle, because you're the SDET, right? You're bringing the testing knowledge to this party. So you're like, oh, okay, well, that was easy. Just need to do more automation. Yeah, okay, more automation. No, not quite that. This too. Can you test this? Chunk of C++ code. Yeah. Looks for something in a binary tree, and if it doesn't find it, it adds it. Okay, that's what it does. Binary tree is a useful data structure. So, this is what I mean when I'm saying know how to read code. And when you know how to read code, you want to then be able to coach the developers in how to write good tests. Because as I said, the typical developer doesn't know test design techniques. You might say, okay, well, they probably don't know black box test design techniques, and that's true. But a lot of them don't know white box test design techniques either. Basic concepts like statement coverage, branch coverage, MC/DC coverage, they might not know. This is where you come in. But you got to be technical enough. You got to be a technical test analyst, an SDET, whatever you want to call yourself, or whatever the organization wants to call you. You got to have that level of technical knowledge. You got to help people understand, help the developers understand what they do and don't learn from the application of these various black box and white box techniques. Yeah, help them find bugs, help them write better code, absolutely, but it can lead to false confidence when it's misused. So you hear developers saying things like, oh yeah, well, I've got these automated unit tests, and so I can refactor my code anytime I want, and don't have to worry about regression. Wrong. That principle of testing that says the test can reveal the presence of defects but can never demonstrate their absence, right? So no regression test is perfect. Regression tests are great, so you got to help people understand that. And help them understand that it's about concepts, not tools. right? All too often the developers, man, they get really geeked out on some tool. Oh, this is great. I love this tool. It's so wonderful. You know, understandable to some extent, but there are a lot of different tools that you can use to accomplish good unit testing. Okay? You need to help bring that understanding. All right. And some of you may remember this movie. Yeah, Matrix. I don't remember which one this was. Not the first one. But I don't think in the first one he quite discovered his ability to do this. That's a handy trick, eh? There's a good, what, 50 bullets flying at him? So raises up his hand, stop. That'd be pretty good, be able to do that. So if you remember at the beginning of the Matrix, there was like the red pill and the blue pill. And Orpheus offers him the choice, right? You take the blue pill, go back to sleep. You wake up, it'll be like nothing ever happened, and you'll think that this is all normal. Red pill, you'll wake up to what's really happening, right? And then remember, what was really happening was that everybody was living in a dream inside this weird sort of collective hallucination inside of a computer, basically, right? So, changing your focus from what we see on the outside to what's going on the inside. Like what's actually happening to your application inside. Like, a lot of times in operating systems, there are ways that they can be configured. You can change configurations of them. Like, for example, in Linux, some versions of Linux, you can enable this switch that will automatically kill an application if it has a memory leak. It'll detect that the application has a memory leak and kill it. That's interesting to know, isn't it? Yeah. If you're working on Linux systems. But this is what I'm talking about, getting inside the matrix, right? You're getting into understanding how this stuff works. Know how dynamic analysis tools work. How much memory is your app using? Is it going up and down, or is it always going up? If it's always going up, that's a sign, I'm not good here. CPU utilization? How does CPU utilization work with your program? You know the patterns by which CPU utilization is affected by the different kind of operations? Yeah, disk operations. You know when your application's going to read a certain amount of data on a disk? Because this can lead to some interesting behaviors. Like stuff that works just fine on your local hard drive, you try to do it on a USB drive, it's like, whoa, what happened there? Throughput, throttle, bottlenecked, right? Because the USB connection, right, is slower than what's on the system. See, normally you don't notice when it's local disk access as opposed to USB drive, you don't notice, right? It's like zip and it's instantaneous. You put it out on the USB connected drive and it's like, woo, wow, that's really slow. With a lot of data, it's going to go slowly. So this is the kind of thing I'm talking about. Notice this isn't automation, right? This is just knowing how to look inside the application while you're running your test, which might be automated, or they might be manual, or they might be some mix of both. Yeah? This is technical tester stuff. All right. I get to go to a lot of places. This is one of them. And John, are you out there? Oh, no, sorry, the other John. Photo. No? Okay. So I'm going to take John's name in vain here. He was bragging about his durian tasting. I don't just taste the durian, man. I am the durian king. I ate a whole durian 2 nights ago. Solo. Yeah. So I like to, get up close and personal with the local culture. So I love Malaysia, but it's hard to top this. This is not a blow-up. I'm sitting in the back of Land Rover in South Africa, and there's the elephant right there. Like, he's just walking up, checking me out. Hey, man, what's happening? So I'm like, move real slow with the camera. I really wanted to reach out and touch him. But, I was like, yeah, that'd be a really stupid idea. Because he's big. He's as big as a Land Rover. I mean, and this was a big Land Rover. This elephant was that big, right? And we got something kind of like that in testing now, which is the data. The data is getting to be a big deal. Now, you may not be dealing with huge quantities of data and maybe diverse data. If you caught my talk earlier on the enterprise challenges of test data management, one of the aspects is that data diversity, disparate repositories. So you got to know what you got to do with data from a testing point of view. Be able to work with it directly and using tools. Do you know how to run a SQL query? If you're working with applications that use relational databases, you should. You should know how to run a SQL query. Do you know what indices do? What is the effect that indices have on system performance? If you don't know that and you're dealing with a relational database, you're not an SDET yet. You got to know that stuff. Can you access the data directly and use that as a test oracle? If so, you might be an SDET. Can you automate directly through the data layer? Yeah, now you're getting to be a sophisticated SDET. Can you read an entity relationship diagram? Do you understand issues of replication and distributed databases and how those affect things like reliability and performance functionality? Yeah? These are really, really technical issues. But if you want to be an SDET, you want to ride the shift left wave. That's your left, right? Shift that way. Yeah. You're going to ride the shift left wave, then this data could be part of it. And it could be a big part of it. Another thing it could be a big part of being an SDET in your future life is security. Right, John Hager? Security? Yeah. Security is big, 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 big. It's a huge issue. We are getting to the point where software is everywhere, all over, and it's making things move in the real world. And as soon as software makes things move in the real world, it can kill people. And that's scary because there are people out there that are not very nice people. And security is how you make sure that people can't figure out how to, override the safety features in a nuclear power plant. Yeah. Happened in a movie, so you go, it's just a movie, but hey, could that happen in real life? You could say, no, that can't happen because all of those nuclear power systems are air-gapped. Just like Stuxnet couldn't happen either, right? Because that was air-gapped. So security. So you should know how to work with firewalls and intrusion detection systems and intrusion protection systems. Know how to use static analysis tools to look for insecure constructs in code and other things. Be able to sit down in a code review or a design review and identify places where security is weak. Encryption. How does encryption work? How does it not work? Reading this article the other night, somebody figured out how to use 200 euros worth of equipment to build this kind of antenna that you could hold near a computer that was decrypting things, and they could break AES 256-bit encryption with that. Woof. That's bad. But that's a lesson there of just because it's encrypted doesn't mean nobody's got the key, okay? Authentication and authorization scenarios, role-based security. Do you know how those work? And do you know how those don't work? And of course, you know, the social engineering stuff. That little Post-it note that's sitting on somebody's monitor that appears to have their dog's name on it or their wife's name on it or something. It's not quite that innocent. They're not reminding themselves to bring home flowers or dog food. That's their password. Okay? It's a bummer to go a long, long way and then not make it to your destination, isn't it? Yeah? How about a few 100 million miles? Oh, yeah. So, Mars mission, polar orbiter. Everything talks to everything else now, you know, because we're in the mobile land. And when something talks to something else, we're talking about interoperability, we're talking about interfaces. And when those two things at each end of that interface don't speak the same language, but they think they're speaking the same language, something bad could happen. Like this could happen. And this is where the Mars Polar Orbiter was supposed to go when it got to Mars. But this is where it actually ended up. Yeah, because newtons per meter and foot-pounds are not the same thing. Yeah, they're not. But that's what they thought. So there was a communication going on between two pieces of software. One was using imperial units, one using metric units, not realizing that they were using different units. Interoperability, integration testing. Who owns integration testing? A lot of times it's nobody, especially if we're talking about system integration testing. I have heard developers say things like, I define my interface, and if somebody's having problems, it's because they're not using it right. What could go wrong with that? That's like an engraved invitation for a miscommunication right there, right? So, who owns it? You could. Somebody needs to, because everything talks to everything else. So, white box, black box techniques, other techniques, get in there, look at the way things talk to each other. We need that tested thoroughly, because you start talking Internet of Things and mobile and all that stuff, and it gets all about things talking to other things. And things go wrong. So, where's the data coming from? Where's it going to? What's going to happen to it when it gets there? Now, you might say, oh, yeah, okay, you're talking about like service virtualization, aren't you? Well, service virtualization is part of it, yeah. But the problem with virtualization is always the possibility of false negatives. Like it works okay when you do it virtualized, but then in reality, it doesn't work so good. So, no, it's not just about service virtualization, but it is about service virtualization as well. Random is your friend when you're in SDET. Be random. Kind of random. So, orderly test design techniques are great, but they can miss things. And exploratory test techniques are great as well, but, it's limited by what occurs to you and what you've experienced and so forth. And sometimes stuff is just weird, okay? There's a write-up of the Intel's Pentium division bug that you can find out on the internet, a guy named Doug Hoffman, where he analyzes this. Now, some of you might be like, Intel Pentium division bug, what is that? And I realize that many of you may not even have been born at that point, but trust me, in the 1990s, this was a real issue, right? And so take a look at it. Doug Hoffman's write-up of the Intel Pentium division bug could not have been detected by any of the structured test design techniques, but it could have been detected by enough random testing. You just throw enough inputs at the thing and check to see, does the result of the division make sense? So, Random is good. Fault injection and fuzzing. Corrupt stuff. See what happens. Does your app know how to recognize a corrupted data file or a corrupted configuration file? Can it handle that? Send corrupted data over some sort of stream. I was talking to some folks in the car industry about 15 years ago, and they were doing a lot of fuzzing and fault injection on data that was going from one subsystem to another in the car, because they're like, it's a noisy world in there. Signals get screwed up on these cables that connect things to other things, and we don't want, like, all of a sudden the brakes like slam on because there was some noise in a cable somewhere, right? So, random. Random for reliability testing, random for security testing, random for functionality testing. Random is your friend when you're an SDET. So, sometimes they say about hunting, bird hunting, the trick to bird hunting is hunt where the birds are. Or with fishing, the trick to fishing is fish where the fish are. And it's like, yeah, that's great. How do I know where the fish and the birds are, right? Or in your case, how do you know where the bugs are? Well, bug clusters, right? Basic principle of software testing. Yeah, bugs are not evenly and randomly distributed throughout the software. They're clustered together. So how do we know where they are? Well, multiple ways. Certainly, if you have defect data and incident data from your testing and your production environments, do this kind of Pareto analysis where you check to see where are the bugs. Yeah. Also, McCabe cyclomatic complexity analysis, that can be helpful. Yeah. There are a number of techniques that are out there. No one of them is perfect, right? But they're all useful. It's part of being an SDET too. Use your technical knowledge to go, where are those bugs? Because you want to know where they are. Yeah, because you don't have forever, right? Because shift left, can mean a number of things, but one thing shift left certainly doesn't mean is you're going to get all the time to test that you ever wanted. Because that ain't going to happen. Okay, if anything, you're going to have less time to test. You may be involved earlier, but remember there's continuous deployment going on, right? So it's great if you get involved earlier, but it could also very well be the case that you're going to be releasing on an even more frenetic schedule than you're used to with Agile, like continuously releasing, like fire hose of software releases. Okay? So you got to get smart. You got to get really smart. Know where to focus. Technical insights will help with that. Okay. Now again, this is something that some of you may have never seen, as this is an oldie and not a goodie from the 80s. That's the Challenger space shuttle. Up and away. And there it goes. How many of you know what happened there? Anyone? Yeah. What happened? Right. Yep. The O-rings, that right there, those solid rocket boosters, SRBs, those are big, huge stacks of solid explosives, basically, joined inside tubes held together with O-rings. Massive O-rings, but ultimately O-rings. And the O-rings were too cold. It was below freezing, which is unusual in Florida, but it was below freezing the night before the launch. One of the launch engineers walked out there and described all the ice hanging off of the structure, the gantries around the launching pad. He said it looked like something out of Dr. Zhivago. I don't know if you've ever seen that movie, but there's a famous scene in that where it's just ice hanging off of everything in Siberia. Dr. Zhivago and ice hanging off of everything in Siberia are not words that you usually associate with Florida, but sometimes it happens. Okay, so this is sad, 7 people died. It's important that you learn from things that go wrong. And what can we possibly learn from a material science failure on a space shuttle? Well, actually quite a bit. So we already learned the lesson from NASA about make sure that you test interoperability, because otherwise you could have a polar orbiter that doesn't orbit, it goes splat. Well, the lesson from Challenger, sure there are lessons about, remember that rubber gets really, really rigid and not flexible in the cold, but one of the important lessons for us is that the night before the Challenger launch, the Morton Thiokol engineers who were in charge of that solid rocket booster gave a presentation to NASA management and Morton Thiokol management. They said, don't launch, it's too cold. And they presented this graph, and it was not convincing because it did not clearly show what the problem was. It like said, oh, we've seen some weird stuff happen with these O-rings when they get cold. That was about it. In his testimony to the United States Congress on the causes of the Challenger disaster, famous Caltech physicist Richard Feynman went and as he was giving his testimony, he sat down, he got a glass of ice water, he took a rubber band and he dropped it into the ice water and he left it in there while he was talking, and then he reached in and fished it out and twisted it and it snapped. Okay, now, if those engineers had done that the night before the Challenger launch, if they had been able to effectively communicate about the risk that was posed in terms that the managers could understand, not some hard-to-read graph, then people might have looked at it and go, oh, that would be bad, right? Because rubber band, O-ring, basically same kind of concept, right? So get technical for sure, but remember, that the people you're communicating with are not necessarily going to be technical. And if you start going on about, coefficient this and memory leak that and blah, 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 they're going to be like, what did that person just say? What am I supposed to take away from that, right? So remember Feynman and the rubber band. Be able to communicate about risk effectively. And by effectively, I mean in terms that your audience will understand. And your audience needs to understand. This is another lesson from NASA. Columbia, the other space shuttle that we lost. Columbia, you might remember, was lost when ice strikes off of the liquid hydrogen tank. That's this thing right here. Ice would fall off of that and strike the leading edge of the wing. And sometimes it would knock tiles, these thermal tiles, off the leading edge of the wing or put holes in them. Well, that's what happened to Columbia, and the engineers knew about it. They'd seen it, but on that launch it had been a particularly bad one. Well, they were like, well, nothing bad has happened on previous launches. Extrapolating from a rather small sample there. And then nothing can be done anyway. Literally, that's a quote out of the report. Nothing can be done anyway, so we're not going to tell them. I think they probably would have wanted to know. The seven astronauts that were in there, they probably would have wanted to know. Okay, so think about risks, think about test results and what they're going to mean from the user or customer perspective, and tell the story. Right? Tell the story that people need to hear. Now, it's not always going to be as dramatic as 7 people are going to die, right? So you don't want to get all melodramatic about this stuff, but keep that in mind, that it's important that you tell the story. Now, I want to be clear here. I mean, it may seem like I have 3 examples, a Mars Polar Orbiter, Challenger, and Columbia as examples here, all NASA examples, at least those 3 NASA examples. May seem like I'm picking on NASA, but I want to give credit where it's due. NASA's safety record is absolutely amazing. If you think of what they do, they put stuff and they put people on top of huge amounts of explosives and shoot them into space. What could be inherently more risky than that? Right? And it's enormously risky, and they've only lost 17 people. 17 people total. 3 people in an Apollo launch test where they had oxygen in the capsule, and then the 14 on the 2 shuttles. Pretty remarkable. And as software engineers, we can be proud that never once has NASA lost anybody due to a software failure. Okay? So if you want to study software engineering done right, you want to go, where do people really, really get this? Go take a look at how NASA does that. Okay? I'm not picking on NASA here just to pick on them. They give some good examples. Okay, so testing is dead. You ever hear that? People saying that testing is dead. I laugh at people when they say that. And then I run into the elevator like these guys out of Dawn of the Dead and I eat their brains. Not really. You guys ever see this movie? Dawn of the Dead? No? Oh, well. Anyway, zombie movies. You know zombie movies, yeah? The zombie shows? Yeah, this is like the original. Dawn of the Dead, George Romero. Right, so the zombies coming into the elevator. Something bad happens next. Anyway, people have been saying testing is dead for like forever, okay? So James Whittaker made a big splash saying that about 10 years ago, went to some conference somewhere in this presentation, testing is dead. Okay, well, that was a retread because Kent Beck actually was at a conference 10 years before that, Quality Week conference in San Francisco in 1999, got up there and said, oh, this Agile stuff, we're gonna make bugs completely obsolete, and this Agile stuff, you're not gonna need any testers. Testing's extinct, you guys are a bunch of dinosaurs. That's what he said. Yeah. So, hey, Kent, I'm still here. So, testing is not dead. It's just back. So I was saying, traditional testing, it's not traditional testing, but it actually is traditional testing is what I'm talking about here. This SDET stuff, this is the original tester. It's like I've got some ties that I've got in my closet that are, like so old that they've been in style twice. It's like clothes is like that. Well, this is where we are. Boris Beiser, Glenford Myers. These guys, total SDETs. Technical testers. Read software testing techniques. And if that stuff doesn't blow your mind, you're not going to go, whoa, this is really intense, hardcore technical stuff. I know it did the first time I read it, okay? They're SDETs. Boris Beiser, Glenford Myers, the fathers of software testing, grandfathers of software testing. They're like, where it all came from. I got my start as an SDET. That's what I was at first. And I'd say I still am. Spent some time writing code, doing automation. I'm an SDET. So yeah, if somebody says testing is dead, just laugh at them because, it's rude to rush in like an undead zombie and eat them. That's just not socially acceptable. And plus it's just wrong that testing's not dead. It's more important than ever. Okay, so shift left and friends is what I've been talking about here, and they're basically just best practices that are actually old friends to us as testing profession. Now maybe you haven't met them yet. Maybe they're not your friends yet. So you want to make them your friend, you got to be an SDET, whatever you're going to be called. Technical Test Analyst, SDET, SET, you name it. Doesn't matter. But But you got to know the kinds of things I was talking about. If you've been sitting here and the whole time and been like, I have no idea what that guy is saying, what is he talking about? You got some work to do, okay? Because this is the kind of stuff that being relevant in the coming decade is going to require more and more and more, okay? So get technical. ISTQB, ASTQB is going to be helping you on this path. We're working on things like performance testing, advanced agile technical tester, and so forth. So there'll be some guidance there. But mostly this is on you. You just got to learn to be more technical, expand your technical capabilities. And remember the thing I said at the beginning, right? It's experience hitting you like a 2x4. So remember Ren McNary's exhortation, often delivered with 2x4 in hand, shift left. Okay, so get ready and shift left. All right, great. Do we have time for questions? Or is it like time for dinner? No questions? I couldn't have been that clear. No? Yeah, it's tough. It's dinner and, yeah, so. No?
Okay. Last call for questions. Okay.
Okay.
All right, and with that, thank you to Mr. Rex Black.
All right. Thank you.
And we hope to see you back here. We've come to the end now, ladies and gentlemen, of day 2 of the 10th edition of SOFTEC Asia. Thank you all for joining us. And one more round of applause to all our speakers, panelists, and moderators for sharing with us these 2 days. And tomorrow is a day for tutorials, so please make sure that you've signed up for your session. And drop by the exhibition, and please fill in the feedback form because we'd love to hear from you. And with that, have a fruitful day tomorrow, and salam hormat, and have a good evening. Thank you.